Now, it takes a certain chutzpah to step up on copper with a parting blade, but don't worry, I got this. Hello Internet, my name is Quinn and this is Blondihacks. I'm back on the vertical fire tube boiler project today and I'm making the burner. This is a gas-fired boiler and so we need to build the gas burner. Now you can buy these but they're a little expensive and they're not that hard to make from scratch as it turns out, so let's go. I'm following this book here, Ceramic Burners for Model Boilers by Alex Weiss, link to this below, so don't shoot the messenger if you have ideas for how to improve these. But it starts with a copper pipe end cap and a ceramic plate, which is actually a jewelry fixture plate for soldering. And we need a big stainless steel spring, more on that later, and of course a gas jet, more on this later as well. To start with, I need to cut down the end cap a little bit. It's too tall for our purposes, so I'll mark a good height on that. And I'm going to do this in the lathe. The base of this has a rounded profile and it's pretty thick, so I can clamp down good and hard on the 3-jaw here and not worry about distorting it. That should be a very secure grip. Now, this being copper, of course, and this being Blondihacks, you know something terrible is about to happen, but not this time, because this time I've got everything figured out. So I'm going to part this off. Now, parting copper is not for the faint of heart, but I've got a very secure setup here, and I'm pretty sure this is going to work. Took my time, lots of cutting fluid. Lathe's definitely working a little bit, blade's digging in there, but I'm pretty sure this is going to be fine. And copper. Now, I've shattered a few parting blades in my time, but this is the first time I've ripped one clean out of the holder without breaking it. That was actually fairly lucky as parting blade failure modes go. Check out this freeze frame here. You can see that blade really wanting to break. I'm very lucky it didn't. But now I have a nice starting groove for the bandsaw, which was definitely 100% my plan all along. Shut up. This thing's a little too small for my big bandsaw. It's too shallow, so I'm just going to set it up in the vise here. Got a machinery jack on the far side to balance the jaws, get a good grip, and I'll just go ahead through here with the portaband. I don't have quite enough clearance around the vise there to get all the way through in one pass, so I rotated it around a couple of times to get all the way through this part. Now it's back into the same setup to face down that edge. This time, everything's going to be just fine. I swear. What? Why are you looking at me like that? See? It went just fine. Conveniently, you can buy these jewelry fixture plates in the exact round size that I wanted, so I didn't have to cut this, but I want a really perfect fit in that copper. Now, conveniently, the pipe is already a little too small, which is good. That means I can open it up. I'm going to set an indicator on my carriage here to get the depth. I want a little bit of that ceramic plate sticking up above the copper, and I'm taking extremely light cuts in here, just like a thou at a time, and test fitting until I get the perfect fit. Because they're both nominally 3 inches, it's just the copper cap here is probably a little bit out of round. And in fact, when the lathe stops, you can see the effect there. I'm really just making it rounder. The diameter of this part is large enough that I can cheat and use a regular turning tool as a boring bar there. But, you know, don't tell anyone I did this. So I did a series of very light cuts, test fitting after each one until I had the perfect sliding fit on that plate. It's a little too perfect, actually. It's probably close to gas tight as is on that fit, and it's quite difficult to get it out, so I'm scared to push it in there too far. Next, I need a hole in the side for the gas jet, so I've got it set up in the mill, and I'm using the edge finder to center it up. Now, I can't actually reach the side, or the equator, if you like, of the round part, but by keeping the edge finder at the same height and going around the long way, you can measure a consistent chord across the circle, which is sufficient for finding the center line. Then I edge find from the bottom to position my hole, center drill that, and pilot drill all the way through. It always pays to plan all your operations ahead of time on a part, and I failed to do that here and didn't account for the fact that my final drill size is too long for this setup in the mill. Yes, I still do not own stubby drills after all this time. I really need to do something about that. However, I did have to move my setup for this part, so I grabbed the angle plate and threw it up here on the end of the table. No need to indicate it in, just basic squaring it up is fine, and I can clamp the part on here. Used the old drill to locate that hole back on the spindle, and then put in the larger drill and drilled that out. Could have saved myself a setup here, but you know, that's how it goes. I gotta say, I love using these can't twist style clamps that I made earlier on the channel from a kit. Go check out that video series for more in my playlists. Next up is the gas jet holder, and for that I'm gonna need some brass, so I'll cut a chunk of this off. The gas jet holder is a thing that holds the gas jet. I know the terminology in model engineering can be confusing sometimes, so stay with me here. I'm gonna start by facing the end of that, as is tradition. Next I'll punch a number 2 center in there and get some tail support going. And let's get this turned down to the OD that I need. The purpose of this part is that the gas jet sits inside it and is adjustable in and out to adjust the air-fuel mixture of the venturi of the gas jet. This will all make sense here towards the end of this video. Alex Weiss's book has nice drawings for all of these gas components, so I'm just making these parts to his specifications. The far end of this gets a shoulder on it that seats in the copper base that we made earlier. This will be silver soldered in. And finally we need a big hole all the way down the middle. This part is basically just a pipe, as I said, that holds the gas jet and allows it to slide in and out. This is really a very simple part. This being a very high aspect ratio hole, of course, I'm clearing chips frequently. The deeper in you get, the more frequently you have to clear chips, because the drill flutes have an efficiency limit on them, and chips will start to pile up on the end of the drill, which causes a lot of problems. You stop making progress for one thing, it wears out the drill for another, and it pushes the drill off course, so you don't get a very straight hole. The more frequently you clear chips, basically, the straighter your hole is going to be. And then finish up with the big drill, and that should do it. I'll break those corners with a file. The edge of the file is great for these shallow shoulders. Little test fit on the base, and that's an excellent fit. I want a nice comfortable sliding fit there because we do need space for the silver solder to live in there. And now on to the other end. I will mark this for length so that I can part it off. You can see that my parting blade needs regrinding there. It's cutting on the far side before the near side, which is the opposite of what you want a parting blade to do. And Yahtzee. We need a few cross holes here, so I'll show a couple of different ways to do cross holes on small round parts. Here's one approach. If you have a vise with a V-groove in one jaw, or if you have a vise that can go in a vise that has a V-groove in one jaw, then that's an easy way to hold the part there, and then you have no trouble drilling through. You start with the center drill so that the drill doesn't deflect off the top of the curve there, and then proceed to drill through. We need one pair of holes all the way through, and these are secondary air holes. The gas jet forms a venturi that draws air in through these holes. Next, I need one hole going the other way, 90 degrees to this pair. So for today's episode of Pointless Precision, I put a gauge pin through the pair and then used an adjustable parallel on the top of the vise jaw to get that pin parallel to the vise jaw. and then clamp it down there, and then I know that this hole will be 90 degrees from the other two. Of course, it absolutely 100% does not matter if it was not exactly 90 degrees. You could eyeball it and no one would ever know. Once again, center drill and drill through only the top in this case. There's no point in making 4 cross holes here because one of them would be up against the ground all the time and not drawing in any air. The last feature we need here is a little threaded hole for a clamping bolt that holds the gas jet in place. So I drilled and tapped this 540. I chose that size just because it looked about right, and it's the same size as the bolts that hold the ring onto the firebox, so I just made an extra bolt when I was making those. That bolt still needs deburring, and according to a lot of angry commenters, chamfering. Deburring features on convex surfaces can be tricky, but that Noga tool does the job. For the inside, I find just running a reamer through there does a nice job of deburring the backs of all of those holes. Just make sure to always run the reamer forward no matter what direction you're sliding it. And that is the gas jet holder. So far, so good. Here's the gas jet itself. As you can see, it's a very simple brass part, and you could make this yourself, except for that hole. That hole is very, very small. This is a number 8 gas jet, which means that hole is 11 thousandths. Now, I have a full set of PCB drills. These are the smallest drills you've ever seen, and they are still not that small. So I went ahead and bought this because I had no way of making a hole that small. The thread on this thing is 1 BA. Now, I know that's common for you Brits, but here in North America, we never see BA threads. I've seen some Whitworth in my time, but this is literally the first British Association thread I have ever seen or touched. So how am I going to mate with this? I started with my thread checker here to see if there was some standard thread that might be close enough, and there wasn't, but it seems to be 28 threads per inch, and the diameter seems to be very close to number 12. So on a lark, I tried my 1228 die, and it fits. So I double checked in the big book, and 1 BA is 28.2 threads per inch and within a few thousandths of number 12. So this does actually fit. Now the thread profile of a BA thread is different, but it'll be close enough to work here. Here's the gas line I'm going to use. It's 1/8 OD copper pipe, typical for this application. It's actually noticeably smaller than 1/8, which will kind of come back to bite me here in a little bit, I think. But it's supposed to be 1/8, so I'll roll with it. Now I'm going to turn down a little piece that holds the actual gas jet itself that slides inside the housing that you saw earlier. So this is turned until I have a nice sliding fit inside the housing there. And that is excellent. That's good. Next I want to drill a small hole all the way down the center of this thing, but not all the way through. So I've got my depth marked there. And then I open up this end of it to the tapping drill size for 1228, as I said, which I'm going to use to fake 1 BA. I'm going straight in with a bottoming tap there because this hole is very shallow. Taper tap wouldn't do me any good. But with the lathe and the spring-loaded tap follower holding it straight, you don't really need the taper tap anyway. Moment of truth. And that threads in really nicely actually, but it doesn't bottom out because there's no undercut on the thread on the bottom of that gas jet. So I'll do a little bit of a counter bore here so I can get that jet to sit flush. Now obviously this boring bar is comically oversized, but the depth of counter bore that I need is so shallow that the clearance angle on the end of the boring bar is enough. So just touch that to the end there, and now that gas jet threads all the way down and bottoms out. It's really surprising how good a fit 1228 is for 1 BA. Like it really is perfect. You wouldn't know it's the wrong thread. Lengthwise, not too critical here. Woodworker precision is sufficient. I just got to make sure that I'm past the end of the interior hole there because I want an L-shaped pipe exit on the end of this thing. I'll deburr while I'm here and part this the rest of the way off. Yahtzee. Back over to the mill now to drill 1 cross hole in this. And for this, I'm using a different method just for flavor. This is a cross-drilling fixture that I built a while back on the channel, so I'll just tap that in. Now the way this works is the V-groove is very precisely exactly in the center of this fixture, so I can edge find on the edges of the fixture itself to center up, and then edge find the end of the part, and come in and drill my cross hole. Now if you were drilling a through hole, you'd want to go in the center of the fixture where the through hole in the fixture is, but this part is so small I can't do it, and we don't need a through hole anyway. This hole is the exit for the pipe. I want it to come out at a 90-degree angle. I cut and deburred the end of my gas line here, and we'll do a test fit here, and yeah, that's quite a bit looser than I had in mind. Again, that gas line is smaller than it's supposed to be nominally by quite a bit, but I think the silver solder can fill that, so we'll give it a shot. So I pickled both parts, and I'll get some flux on the end of the pipe there, and I'll attempt to fixture this in there. I've got it fixtured vertically so that the solder will run down into the brass part there. Little ring of solder on there, applying the heat mainly to the larger part until that solder flows. And that seemed to go very well. That's a jewelry fixture plate that I'm using there. Great for little parts like this. And I finished by washing some heat around to make sure it flows on all the surfaces. That joint looks very good. I'm sure it's gas tight, which it needs to be so that the fire stays where we want it. After pickling, that joint looks very good indeed. In fact, if I blow on the end, it's a little too good. Yeah, it's plugged, unfortunately. So I tried drilling it out, but as you can see with the air compressor on there, no air is getting through. So I had to cut that pipe off, and I need to drill this out and try again. I need a different setup. Clearly the silver solder flowed into the end of the copper pipe and plugged it up. So I used a small drill to line that hole up on the spindle, and then I just plunged straight down with a 2-flute center cutting end mill the same diameter as the pipe, and just milled all of that silver solder and pipe detritus right out of there. This is not normally a problem with these copper pipe fittings, which is why I wasn't worried about it, but the ID of this gas line is so small that the silver solder had no trouble bridging it by mistake. For the second attempt, I'm going to use a trick that many viewers have suggested. I've got some correction fluid there, whiteout as it might sometimes be known, and I'm going to apply that right around the very end of the pipe to keep the solder away from the very end of it there. And I flux the rest, put my ring of solder in there, and I'm feeding it in, and I've got a drill as a backstop to make sure that the copper doesn't bottom out in the brass there, which also might have happened in the previous attempt. And I've got the setup sideways so that the solder doesn't flow down to the very end of the copper pipe there, hopefully. And apply some heat. This worked fine, except because of the sideways setup, I had to use an old pick that I don't care about to nudge the solder into place. It didn't want to flow down into the joint there. Once again, joint looks good. And after pickling, again, clearly gas tight, no trouble there. And this time, I can in fact blow through it. Result. Now we'll see if that joint leaks later, but for now I think we're ready to go. So I'll put some Loctite on the gas jet. Now it's time for the gas jet holder to be attached to the base. So I got some flux on that. Install it in the base vertically so the solder flows down into the base. Put a ring of solder on there, and then I'm applying the heat primarily to the copper base because it is by far the largest mass in this joint. And I just work that around. Once again, I've got a stainless steel scratch rod here with some flux on it to just coax the molten solder into all the areas that I want it to go in. It's threatening to run down the sides of the copper there, so I want to make sure it flows into the joint. And then once again finish by washing the heat around everywhere, make sure that all the metal surfaces have contact. Once more into the pickle bath, dear friends, and then a rinse to clean that up. I think that is going to be a good joint as well. And yes, that joint looks excellent. Very nice. That one also needs to be gas tight to keep all the fire in the places where fire is supposed to be. Little test fit here. You can see how the two components work together. The gas jet slides into the holder, and then the little set screw or set bolt. Is that a thing? Anyway, set bolt holds the gas jet in place so that you can have just the right air mixture going in there. Then I shined up all those parts on the Scotch-Brite wheel, and then I clear coated them to keep them from tarnishing. Now on to paint for the copper base. I taped up the brass parts and then out into the alley with the barbecue paint that you've seen me use before recently on the firebox. I've been really pleased with this stuff. It holds up really well. It goes on very easily. So a couple coats of that. And then I can pull the tape off. And this is starting to look like a burner. Pretty pleased with that result. Let's move on to the fuel system now. This is the fuel I'm going to use. It's typically called camping gas. It's butane with a little bit of propane thrown in to help stabilize it over different temperature ranges. This stuff is nice for model boilers because it's low pressure. These canisters are like sub 5 psi, and so you don't need an external regulator for them. You can just run them straight into a gas jet. It doesn't burn as well as full propane does, but propane is stored at very high pressures, so you need a regulator if you're going to use that. These little camping gas canisters are great to build into steam plants and things like that. They're also easy to plumb into because they have this standard thread on them with an internal valve activated by a pin, and you can buy external valves for these things. This valve is a Bix Gas Tank Valve. It's extremely nicely made, so I purchased this rather than blow myself up trying to make one, but I do need to match that fitting. So it's a union cone style fitting, appears to be 60 degrees from my fishtail gauge here, so I can make that over on the lathe. I actually took some measurements off that gas valve and modeled it in CAD to make sure I get these parts right. So starting with the little cone fitting, I turned that down to the largest OD of the cone. Then I used a grooving tool to create the recess at the back. This is a really quick way to make these little cones if you want to make a lot of them. Once that's at the correct diameter, then I can pilot drill and drill out the center. And this diameter matches whatever the pipe is that it's going to slide over. I'm drilling it a little undersize here now that I know that my 1/8 inch nominal copper pipe is a lot smaller than 1/8 of an inch. And then for the cone portion, I just use my threading tool, which has the correct angle on it, 60 degree included angle, 30 degrees. And I just use that as a form tool, and I bring that in until the peak meets the hole. Then part that off to length. This CAD model that you see, by the way, is all parameterized, so you just specify the size of pipe that you want, and it will generate the cone and the nut and the inverse cone for the fitting that you want. So you can generate pipe unions automatically. Go check out my Patreon for those files. Next, onto the nut. I start with the through hole, and then we need to create a little shoulder. So for that, I use a flat grind drill, and I need to get this depth very precise. So I'm putting an indicator on the tailstock, and then I set the front edge of the drill with a feeler, add that to my depth, and then feed in very precisely to that depth. That shoulder has to land in exactly the right place relative to the length of the nut. Then I use a parting blade to round the top and bottom edge of the nut, which is just a traditional detailing that these usually have. Just aesthetic, but it does look nice. And then I tap the hole using a bottoming tap right up to that shoulder that we made with the flat grind drill. I'll do a test fit on the valve there, make sure that's the correct fit and that it goes in far enough. The depth of this hole is critical as well because it needs to cover the union cone and still have enough thread engagement to seal up. And finally, parting it off. There is our nut. So here are all the pieces. You can see how they all go together. So the cone fits through the back of the nut, like so. The threads go over the nut, and then the cone seats into the female cone on the valve fitting there, and then the nut threads over top of everything. It pulls the cone down tight and seals it up. And that is a gas-tight seal with no Loctite or anything required. So now we just solder that cone onto the end of the pipe. First step, very important, put the nut on over top and make sure it's the right way around. If you don't do that correctly, boy, are you going to be sad because you're going to have to make parts over again. Okay, let's do a test fit here and check for leaks. So I snug that up onto the valve and turn the gas on. I've got the other end plugged. And yeah, some soapy water reveals I do have leaks, so I heated that cone up and put a little more solder on. I had a pinhole there around the base of that cone. So tighten that up a second time, and once again, turn the gas on, soapy water on there, no leaks on that end, looking good. And I'll check the other end as well, down here where the gas jet is, no leak around there, so looking good. Let's do a little test firing here, and sure enough, it is a gas jet. It's a little hard to keep it lit because the gas jet is so high velocity. You have to turn the valve way, way down to keep a little flame lit on there. It's how gas jets work. They're very high velocity. But it works and there's no leaks. To assemble the burner, I'm going to need some adhesive, high temperature, specifically for ceramics. But make sure that you do not use this stuff, Fireplace Cement. There's two categories of these adhesives. There's grout-based products and silicone-based ones. The grout-based ones, as you see here, will fail on the first heating because they can't expand and contract. So make sure you're using the silicone stuff, and it has to be high temperature silicone, specifically for fire barrier, not like the 600 degree silicone, but the 1000 degree stuff. To diffuse the gas inside the burner, I need a little piece of stainless steel mesh, so I'm cutting that out. This is all straight from Alex Weiss's design here. I'm not inventing anything, I'm just following what he says to do. And this gets glued in front of the gas jet inside, like so. And then you take one of these big stainless steel springs and you glue that in front of the gas jet opening. And that apparently swirls the gas in there and distributes it evenly. Again, I have no idea if this actually works. I'm just following what the book says to do, and we will see. Then the ceramic top goes on, and I press that down onto that very tiny ledge that we bored into that so that it sits at the correct height, and then another layer of that caulking around the outside. Just like any other silicone caulking, you can apply this on fairly liberally and then use a wet finger to smooth it out and make a nice looking edge when you're done. I did find you want to use gloves with this stuff. It's quite a bit more nasty than regular silicone in that it sticks to your fingers and irritates your skin and stuff. But that's the final result. Now, once that's cured, let's give it a little test light. The light's turned down a bit so I can see what I'm doing with the flame. Let's give it a test light here. So it's a little bit difficult to light, but there it goes. Now, the way you set the gas jet on these things is you push it all the way in, and the flame will turn bright yellow or orange. And that means there's not enough air, and then you pull it out until the flame turns blue, and then the mixture is correct. But if you pull it out too far, the flame goes out. I'll turn the lights down further so you can see better. So there you can see the blue flame covering the burner. Now, ideally, you're supposed to apparently have those little blue cones in the back covering the whole thing, and I don't quite have that. So this burner is not working quite as well as the ones in the book apparently do, but you can see me playing with the mixture there. That's not enough air, and pull it back out a little bit, and not too far, or it goes out again. It's very fussy, this thing. You got to get the gas pressure just right and the air mixture just right in order to get something that's easy to light and will stay lit and burns efficiently. I did a lot of experimenting here with this, and I didn't get a setting that I loved. This is about as good as I got it, and it's working okay, but it's certainly not perfect. I tried a couple of things to improve this. For example, I thought gas distribution might be the issue, so I pulled the burner off and I put some copper wool around in there to help maybe distribute the gas better, and honestly that just made it louder. That made no difference that I could tell in the flame. Some of my patrons suggested the holes in the ceramic plate were too large. This seemed like a really good suggestion and it made a lot of sense to me, but at the same time I was stumped by it because I really couldn't find any smaller holes on these ceramics fixture plates. They all seem to be the same size, and it's this size, and this does seem to be what Alex is using in his book, but it's hard to say for sure because there's no scale in the photos. But after a bunch more research, I did find there is a smaller size option on these fixture plates, but it's very hard to get. I went to multiple jewelry specialty suppliers, and I only found one that sells this smaller size. This is from Rio Grande Jewelry Supply. I'll link to it below. But I was excited to have this option to try, so luckily the old burner is easy to remove. Just slice the caulking off and it peels right away. Now, unfortunately, the old ceramic plate is really wedged in there, and you can't pry on it because you will crack it and shatter it. These plates are very fragile. But here's an easy way to remove it. Just heat the bottom of the base there until it expands and the old ceramic plate just drops right out. I've done this trick a couple times when I needed to experiment with this burner. Now the new one doesn't fit quite as nicely as the old one does. It's not quite as well made as the previous one was. It's not as round, so I couldn't get it in there, but a little bit of work with 80 grit sandpaper and I could take away the high spots. The stuff sands quite easily with 80 grit, and I was able to massage it until it went in there. I'm going to do a test here before I push it all the way down and caulk it in, so I'll turn the lights down again and let's do a test light here. The ideal gas pressure for lighting is a little higher with the smaller holes, so I got to get used to that here. So once I get it lit, I'm now going to reset the mixture here because it might need to be different. So I'm going to do the same thing as I was doing before, the standard way to set these, which is to push the gas jet in too far so the oxygen is too low, get the bright yellow flame, and then pull it out until the flame turns blue. And so far that looks like it's burning very well. I do notice that it's much more stable than before. The old one with the larger holes would blow itself out very easily if you pulled the gas jet out even a micron too far, whereas this one seems much more stable. In fact, I can pull the jet all the way out to where you get underburning. You can see the ceramic glowing orange there very rapidly, and that's because it's actually burning gas under it and heating it from below, which is very bad for the ceramic. So I shut the gas off immediately there, but right off the bat, this is definitely an improvement. So I think I'm going to roll with this, and I put the caulking on and smoothed it out once again. Let that caulking cure overnight, and let's give it a test run. Still a little tricky to light. I'm getting used to the gas pressure here. And I'll adjust the gas valve a little bit there. I fiddled with the gas valve with the caulking in place because it's a better seal now, so the setting is a little different. And I settled on this spot right here, which seems to be burning quite well. There's no underburning, and I do have a fair number of the little blue cones that you're supposed to have. And, you know, while it's not covered in little blue cones, it does look like the pictures in Alex's book for a well-performing burner. I can turn the gas pressure up and down, and it seems stable, so I'm quite happy with this setting. I think this will definitely work in my boiler, and I'm going to roll with it. Thank you very much for watching. I hope if you're building a model boiler, you'll give it a try building your own burner like this. It was a lot of fun. And if you can swing it, throw me a little love there on Patreon. That's what keeps this content going. And I'll see you next time.